Okay, so what can the limit definition of the derivative tell us about the derivative of a sum of functions? Even if we don't know what f in particular or g in particular does. Well, first off, let's recall what the limit definition of the derivative is. Remember, if I'm taking the derivative of just f of x, then that's going to be the limit as h goes to 0 of that function applied to x plus h minus that function and all of that over h. So in this particular case, I need to apply this overall function to x plus h and to x, put it over h, and take a limit as h goes to 0. So I should end up with something that looks like this. Here again, if I plug in x plus h into this overall expression, I'm going to get this green piece. If I plug in x into this overall expression, I'm going to get the purple piece. And notice here, you do need to encase this in parentheses because you are subtracting all of that expression. You are subtracting all of this. If you don't put those parentheses in there, you'll forget to distribute a negative. Now at this point, something might catch your eye. Look, aren't the pieces of this expression here sitting inside this expression somewhere? I mean specifically with regard to the function f. Here's an f of x plus h. There's an f of x plus h. There's a minus f of x. There's a minus, if we distribute it to, an f of x. And of course all of this is over h, and all of this is over h. I wonder if we couldn't isolate this limit here within this larger limit. Let's see if we can do that. Let's bring this f of x closer to this f of x plus h. Okay, so now you can see I've just taken this negative f of x and put it over here, and I've left a g of x plus h. There he is. And I also have left a minus g of x distributed there, and that showed up here. Look right there. Isn't that this expression? Couldn't I break this apart into two fractions so that I would be looking right at this expression? Let's do that. There. Now I've drawn that expression that we were interested in red, but look what happened to the rest of it. If we split this fraction into two fractions, does this right-hand side in blue look familiar? If I take the limit as h goes to 0 of this blue expression, isn't that the derivative of g? Right? It looks identical to this up here, just with all the s replaced with g's. And remember, the limit of a sum is the sum of limits. So I am free to, quote, distribute this limit across. That's not really a distributive property there, but I can put this limit on this expression and put the limit on this expression and add the two resulting limits, and I get this. Let's do that. Okay, so there's the limit of the red expression plus the limit of the blue expression, and those are identically the derivatives of f in this case and g in this case. So we have this. The derivative of the sum of two functions is the sum of the derivatives of those functions. That's a nice rule. Now, one more thing. I will say that we can only apply this rule if, of course, the derivative of f actually exists, and the same thing for g, if the derivative of g actually exists. But that's a small caveat. In general, the derivative of a sum is the sum of the derivatives.